Are we allowed to get help from accent or exams?
Please, yes, please do. So yeah, guys, somebody was asking me just now if you can get help on corrections to anything, quizzes, homework, tests. Yes, dear God. Don't rely on the person that made the mistakes in the first place to fix them. Right, so you can come see me for help. You can say, can you look these over before I turn them in? The worst thing for me is to look through stuff and give you no points back because they're all still wrong. Right, you wasted my time. What the shit? So nothing wrong with coming by to see me and saying, can you look at these? Tell me anything I need to work on still. And then if you got time, sit down and I'll help you. That's insane. Yes?
How many times can you turn in corrections?
Once. This is not English class.
Okay.
There's no first draft, second draft. No. None of that shit. Right? I don't want to suddenly teach English. You don't want me, obviously you should have enough evidence that you don't want me teaching English. Grammar me no good. Okay. All right. Any lingering questions over what we did a minute ago or 20 minutes ago? No, okay. All right. Because we are insane, we're going to jump into probability. Oh yes. So I'm going to show you a problem. This problem is really nice to start with, and I definitely always give this kind of problem on a test if you happen to have one coming up. So let me write this down and see if you guys can interpret what this means. So I ask a group of men and women a question. Can anybody tell me how many women said no? Okay. How many men said maybe? How many total men were there? 63, there it is. All right, so let's do that. Let's do some totals here. So there's 63 men. How many women? Yeah, 55. How many people said yes? 7, 3, 8. I guess 118, right? Yep. Do you see why somebody might put 236 here? They'll add these people with these people. Well, what's weird about saying that? These people are these people, so don't add them twice, right? Somebody with this so far? This is nothing major. I'm just counting people with what they said so I can identify subgroups and then analyze why is there a difference? How big is the difference between these opinions? And I'm going to leave it up to your imagination about what the question might have been. Okay. So this is what's called a contingency table. I'm going to take some of the data you provide me from that survey. And yes, if you have not done the survey yet, do it, please. I'll send out another email. But I like to make problems based off of what you tell me, so then you can get a feel for who are these people you're sitting around. So let me ask you a question. If I pick one person at random, what's the probability that I pick a woman? So let's get used to the notation too. I like it. So probability, the basic idea of a probability never changes. It's always the total number that match what you're looking for divided by everything it could have been. So can you see why somebody might say, now this is the wrong answer, obviously. But I always get somebody telling me the answer is 1 out of 55 for this question. Can you see why they would say that?
Oh, yeah. Because the total number of women is 55. So
And they want one of them, right? So that's that thing, but that's not what probability is. Probability is the relative chance of getting something. So it's always the number of things that match what I'm looking for divided by the total things it could have been. So how many chances do I have of randomly selecting a woman? I have 55 chances out of 118. What's that? 0.46. Keep going.
1.
Stop. So we'll take probability out to 4 decimal places in general. So you might pick up on this. If you just round everything to 4 places, because what standard deviation? It's got to be at least 3. So you can go 4, right? You start to see what I'm saying? If you just take everything out to at least 4 places, you're gold, right? Or not. Okay. So pretty cool so far. So this sample was made up of mostly men, just arbitrarily. There's a little less than half of them were women. So there were more men than women. Okay, that's great. So this is really just, are you able to read this chart so far? So can anybody tell me what's the probability I pick a man who said, a man and they said no? Huh? 42 out of?
53.
No, careful.
66.
The only way the bottom can change is if I know something about the person. So look at this question. I pick a person. What's the probability they're this? How many people could it still be? 118 people. We're going to see a problem in a minute where I give you more information. What if I told you it was a woman? How many people could it be then? If I told you it was a woman, how many people could it be?
55.
55. Then the bottom would be 55. If I told you that. Did I tell you any information? No, I didn't tell you a damn thing. What's the probability it is a man who said no? Did I tell you anything about the person? Could it be a woman? Yes. Could they have said yes? Yes. Right? What's the probability that they're a man who said no? So do I know shit about this person? No. If I pick a card and I say, what's the probability it's a black card and it's king? It's a king. How many cards could this card be? Still, 52. I didn't tell you anything about the card. I'm saying, what's the probability it's a king that is also black, right? You guys with me?
No, I'm just. Are you talking about like the entire portion? When you were saying that, like you didn't tell me anything about the card specifically.
Yeah, you don't know shit about the card.
Okay.
So how many cards could it be?
Well,
52?
Wait.
There's 52 cards
It
in
could
the
be
deck.
52 cards, but only 4 of them were kings. Though.
I'd like so it would have been 4 out of 52. But I said
Okay.
it was a king who was black, so it would have been 2 out of 52.
Yeah.
All right. Anyway. All right. The whole thing here is the bottom will always be the total number, unless I give you, and I say it like that because that's actually a word we use, given. If I'm given more information. Does that make sense? If I pick one person random, what's the probability that this happens? Okay, the bottom is going to be freaking 118. Unless they say, oh yeah, it was a woman. Now the bottom would be 55. I like it. Let that make sense. So any probability, the idea never changes. It's just the bottom is the total number of things it could be. And if they say it's a woman, well now it can only be 55 things. I'm going to throw all the dudes out, right? Maybe. I always like to look around. So yeah, how many match what I'm looking for? 42. And of course, we just got done saying it could still be any of the 118. And whatever the shit that is. What is it? 0.3559. Yep, okay. How's everybody? Yes? Nope, this is chapter 3, yeah, dude.
Yeah.
After this week,
this
we're
the beginning
1/4 of the way through the semester.
The beginning of chapter 3?
This is the beginning of chapter 3, because this is the first time I'm talking about it. Okay. So let me go ahead and follow this right up with an example of what I was just saying. What's the probability it's a man given that they said yes? Now, somebody help me out. That people misread this, but I really want you to be able to see what is it that I know about this person. I don't know that they're a man. Let's read this again. The probability that they are a man, given they said yes. So what do I know about this person? They said yes. Glad I didn't hear any men. Okay. Right? You guys with me? Do you see how to read this notation? The probability that they're a man. I don't have a clue if they're a man or not. It's saying what's the probability they're a dude. Given they said yes. So what's going to be on the bottom?
57.
Yeah, 57. It could only be some of these people. So look what you could do. You could physically cover this thing, right? The rest of this shit don't mean anything for that problem now. I can throw all these people out. I'm just focused on this. So if out of those 57 people, how many match what I'm looking for?
18.
Beautiful. You wouldn't be, why is this wrong? Why can you immediately tell this is wrong? This is a mistake. Don't write that. Why is that wrong? Good. That's a very direct reason why it's wrong. What's another quick way you can tell that's wrong no matter what? It's bigger than frickin' 1, right? So you can do the psychological thing about going to give 110%, coach, right? That's a psychological thing. You can't give more than 100%, but 110% is that psychological, amping yourself up. I get that. You with me? So you can't say there's a 120% chance of rain tomorrow. Does that mean the raindrops are bigger than normal? Does that mean that it's going to rain down and up and sideways? What does that mean? You can't be bigger than 1 or 100%. If you get that answer, don't just circle it and keep going, because I'll cry. And if you want me to cry, you could do that, and it'll make me cry a little bit. You see these tear marks on your paper? If you see this happen, this is bigger than 1. Go, I did something wrong. Let me go figure out what that was. Or if you're in a test and you're like, it's the last one you do, and I'm like, give me your papers. Just write, I know it shouldn't be this, but I don't see why. Do something, and I might give you an extra point or two, because I'm like, at least show me that you know that's wrong. Don't just circle it and go, yeah, everything's good. So, of course, I'm sorry. What should it be? 18. It's very cool. So this given, the given, tells me to eliminate some possibilities. But it's still going to be the number that match what I'm looking for out of what it could be. That idea actually never changes. I love that shit. How are we doing so far? All right. And what is that? Sorry. Point 315. Ooh, I guess some dissension.
8.
8. Because this is a 3157.
I just didn't round it.
Ah, okay. Yeah, okay. Let me take a step back. What's probably as a dude? Yeah, it'll be 63 out of 118. Is that cool? And what is that? Do it again, sorry? Yeah, it's going to be 1 minus that, so 0.5239. Yeah. Okay. 0.5339. Thank you. All right, now watch this. It's kind of cool. You ready? You ready? Let me see if you guys really, really get this. Do you see how these two questions are fundamentally the same kind of question? They're both questions about the probability it's a dude. One of them, I don't have any more information. The other one, I do. Does the probability it's a dude change if I know this? Does the probability it's a dude change if I know this? Yes. Look at the numbers. Are they the same? Are these the same? Okay then. The probability it's a dude is 53.39%. If I know the person said yes, does the probability it's a dude change? Yeah, it goes way down. Right? So would you say that the probability that somebody saying yes changes the probability that they're a man or a woman. Would you say that? Yes. So would you say that man, being a man in this sample and saying yes in the sample are dependent on each other? The probabilities are dependent on each other. Does the probabilities of dude depend on if I know this or not? Yes! What does it mean to be dependent on something? If that thing happens, you change. Right? Isn't that what dependent means? All right, let me say this again. Does the probability that it's a man change if I know that they said yes?
Yes.
So does the probability it's a man depend on whether or not they said yes?
Yeah.
Does the probability, I'm not saying that somebody goes, no, I mean no, and then they turn into a woman. That's not what I'm saying. I'm saying, does the probability that it's a dude change? Is it dependent on if that person said yes or not? Of course it is. It's a much smaller chance. So if I know the person, if somebody's like in the next room, there's this guy, there's a person who said yes. Well, now I know it's much more likely that's not a dude, right? Because the probability as a man is really low compared to what they are in general, right? And of course, looking at the data, very much fewer men said yes. So of course that kind of bears out. But now I have a little more specific percentages to work with. All right. So there's this idea of independent versus dependent. If this number would have been exactly the same, it would have been independent. Probably a man wouldn't have given a shit about what they said if they would have said it, and that would be independent, right? If you are independent from somebody else, you don't give a shit about what they do or say, right? You like it? You don't stalk them on Facebook, right? That would still be dependent. All right. Guess semi-okay?
I'll write that down.
We're going to get deeper into that in a minute. Yeah, I just wanted to put that out there right now since I had those two probabilities to play out. Well, let me see. Let's go ahead. Go ahead and talk. I'll go ahead and do it. So how can you tell if two events, let's call them A and B, so event A could be you win the lottery, and event B could be you get struck by lightning, right? And then you want to know, are those independent or dependent on each other? I don't want to test this out. Come on, lightning, increase my chances. No, I'm holding up a metal rod. Okay, so if I have two events, I don't care what the shit they are, but like the event variables and probability are these capital letters. A is an event. What is it? Anything. It's a variable for an event. B is some other event. Right? An event could be rolling a 5, or your car tire coming off your car, or whatever. In order for them to be independent, now watch this. I hope to God, I always am so hopeful about this. If the probability of A given B is the same as what the probability of A was by itself, does A give a shit about B? Do you see that? That's it. That's all there. If I know B happened, if I know B is true, I love the look on some of your faces. If I know, so given B, so whatever the hell B is, it happened. Did A change because of that new information? What's this say? The probability of A stayed the same. Does A give a shit about B? Wouldn't you call that they're independent then?
Yeah.
Thank God we do that. Sometimes math people pick the right word. So if I ever ask you, is this and this, are they independent? You don't give me a big ass paragraph. Well, you could be this and no. You gotta show me numbers. Right? So are those independent? No. Because the probability of man given yes does not equal the probability of man. So man does give a shot.
If they're equal to, then it's dependent.
No. Test for independence. If this is true, then they are independent. Alright? If I tell you B happened, and A's probability does not change, see how it's the same? Then A didn't give a shit about B happening. Hey, A, B happened. I don't care. Right? Here, person said yes. Oh, the probability the dude went way down. It was affected by this knowledge. Therefore, in this case, they are dependent because these numbers are not the same. If I tell you they said yes, the probability the dude changes from what it was. I like it.
So as long as event A wasn't affected, then that means that they're independent.
Yes. Or, the other way, you could say B given A equals probability of B. It doesn't matter which way you look at it.
Okay.
So just to make sure, so for dependent, A changes because B happened. So
In order for A and B to be dependent, then the probability of A would change if I told you that B happened. And that kind of jives with what we know dependent means, right?
How would that look like as an equation if it was dependent? If A was dependent on.
There would be a not equal to.
Oh. Okay.
Yeah. So the only way they could be independent is if those two are equal to each other. So most things are in some way dependent on each other. Some things aren't. So for example, there's a tree right now at a certain position in Japan, right? Is its height dependent on how far I can jump? No, so those are independent. So anyway, that's a really stupid example, but it's really kind of difficult to create a situation where things are really truly independent. Because we're affected by almost anything we can see. So if there's something you can't even see, then it's going to be independent. You're not going to be affected by it if you can't see it. Now, anyway, I'm not going to get too deep into this, but we'll do some cards later. I don't know if anybody's not good with. Does everybody know how many suits are in a deck of cards, for example? No, okay. So maybe I'll do something else. Sort of like Lucky Charms, but not really. Okay. Well, this will come back up in a minute. I want to keep going with these. Yes.
Can you explain again the independence, how it goes with the male?
So since the probability of man, let me show you this symbol because I'm getting tired of writing this word. The symbol for given is just a line. Man given yes. Since that does not equal the probability of man, they are dependent. Dependent. Yeah, there it is. So probably it's a dude depends on if they said yes or not. And I can see that. If they said yes, the probability goes way down. So I bet you if they said no, I bet you the probability goes way up. Yeah. And I could calculate that. Okay, maybe. All right, so let's do one more with a given. Let me show you this turned around a bit. Where am I at my Roman numerals? Here we go. What's probably somebody said yes, given they're a dude? Just kind of turning that around. What's going to be on the bottom? Because what do I know? I know it's a dude, so it's 63. I like it. So what's the only thing that exists now in my universe? What can I cover? Yeah, the only thing that exists is that first row. I know it's a dude. Given it's a dude. Because probably they said yes.
18.
Yeah, 18 out of 63, yeah. Whatever the hell that is. 927, so like 0.285. So. Yes, maybe. If you're still having some trouble with that, you got some time to get on it, yes?
Is there a reason for making these decimals and not percentages?
Oh, you can take one more step and make it a percentage. I'm just saving space. Making it a percentage doesn't really change it. So you can if you want to.
So when it's not even, it's just
Beautiful. So what's the only time the bottom won't be the total number? If I'm given information, right? I like it. Kick ass. All right, continuing on. Oh my God. Let me all right, I might as well do this. Let's develop the formula. Well, we can't do that yet. I gotta do one more. I kind of did this out of order because the given came up too early. Let me do another. Here we go. I did do that, didn't I? Okay. All right, I like it. I can't do this, I'm sorry. So if I have the probability of A given B, let's piece together what the formula would be. Notice something. We're about to develop the formula for given. Have we done any problems that are givens? Have we done problems? See how we did them before we had a formula? So this is a really weird statement to hear a math teacher say. The formula gets in the way sometimes. So probability is remarkably simple. It's all about counting. So if I give you stuff to count, don't use the formulas. Formulas have to work no matter what. So they are always going to be a little bit worse than some situations require. Will your teacher give you situations where you don't have everything to count? Oh, hell yeah. So you're going to have to use a formula somewhere. But now we can see what we did and make a formula based off of it. Who are these 18 people up here? The men who said yes, right? Like the knights who said yes. The men, so what? So the top here was men and yes, right? So in general, the A given B, the top will be A and B. Everything that's both. It kind of makes sense. Who are the only men, let me see which way I'm going to go. Who are the only people that said yes that I can include here? They must also be a dude, because I know it's a dude. So the top has got to be everything that's both, because that's the only thing that I could put on the top. That's the only way it could be in there. And then what was the bottom here? What's 63? That's related to the probability it's a dude, right? So on the bottom, it's going to be probability of the given. The bottom is always going to be related to the given thing. This is our first real probability formula. Okay. I like it. What about, let's do one more, I think. Let's see. So probably they're a woman, or they said maybe. So what is wrong if I say, okay, 55 women, 8 people said maybe, so 63 out of 118? Yeah, you're counting people twice, right? So here's women, and there's the ones who said maybe. So if I do 55 plus 8, that's too many. How many do I have to subtract off? Everybody who's both, right? So if I add these people to these people, I've counted that one twice. Oh, okay. I like that. In fact, something I didn't say about and before, isn't that going to be the and, women and maybe? Do you see why and very often is called intersection? And is also called an intersection. Bam. It's where they intersect. Okay. So I'd have to subtract off 5. Now, if I was doing this, I would just say 55 women plus 3 maybes I haven't counted yet. Right? Wouldn't they get to the same place? So you can be smart about it. Don't even double count them in the first freaking place. Just don't do 55 plus 3 minus 5. Don't overdo it. Right? And then what's going to be in the bottom? Yes, because I don't know shit about this person. So I get 58 out of 118, whatever that is. Somebody gonna help me out? Hey, come on, Matt boy, you want to show off? Who? 0.4915. Okay. I'm gonna try to see if I can stop somewhere cleanly in here. Well, not really. Okay. Basically got it all done. Alright. So let's develop a formula for or for the situations where Jeff's gonna be a dork and not give you stuff to count. I have to use a formula then. So let's piece this back together. What was this? That's the probability that it's a woman. What was this? Probably maybe. And then what was this? I guess I do have to say it. Yeah, probably of both. Right? And that would be the probability of woman or maybe. Warmaby. Probability of Warmaby. So the probability, now this is really interesting what we're doing. I want you to see this happens in math more often than you think. You do something based on logic, and they go, what did I just do? Let me make a formula out of what I just did for the situations that are just like this but are freakier. That happens not all the time. It's not the main way we do shit, but it does happen. Oh, thank you. I need to hire a cinematographer. Okay. So in general, probability of A or B equals probability of A plus probability of B minus probability of both. Real quick visual. Have you guys ever seen a picture like this before?
Yeah.
It's called a Venn diagram. So if I want the probability of A or B, if I take everybody, all the A's and all the B's and add them together, I've counted this part twice, right? And what is that part? That's where they're all A and B. So that's why I would subtract that part off. So that's the visual of what's going on there. Okay, all right. Oh, maybe I can. Yeah, maybe. I'm trying to cut this down for you guys, but it's not going to be easy. All right. Let me give you this. Let's see how much of this I want you guys to do.